All right, this is the Geometry Unit 7 review video. I'm going to go over each of the sections in detail, tell you what your answers should be looking like, and yeah, I'll answer everything here for you. Try to give detailed explanations for as much as I can. But we are going to start with the first section here. We have a diagram with a list of terms. You need to know each of these terms, what they mean, and what they look like when viewed on a diagram. So you need to be able to actually identify an example of each one. So if we look at the first one, we'll be looking at the radius. And the radius is going to be the line connecting the center of the circle with a point on the outside. So if we look down at the diagram, we're going to see that A is the center of the circle, and the center of the circle is going to be connected to any of the following points. You could do AG, AF, or AH. I'll show an example here. There's A, and you could connect it to any of those points I mentioned, H, G, or F. Let's go ahead and just look at AG. So AG would be an example of the radius of the circle. And so we're going to go up, we're going to write our answer. Oh, sorry. Let's look at AH, also an option, and AF, also an option there. All of those are examples of a radius of this circle. So we write our answer by writing two letters. In this case, I'll do AH, and then drawing a line above. That line is saying this is a line segment, and that is part of the answer. You must have that line segment written the correct way. In fact, all three of these, radius, diameter, and chord, are going to be line segments. So looking at the diameter is the line segment that goes all the way across the circle, crossing through the center, in this case crossing through point A. And so we can see it's going to be HF. That is going to be the diameter of this circle. And so again, we'll go HF, and we will put a line segment above. Line segment symbol to show that it is a line segment. So again, diameter is a line that goes all the way across the circle through the center from one point on the outside to the other. All right. So looking at chords. A chord is a line segment connecting 2 points on the outside of the circle that is not the radius. So we have an example here, DG. DG connects 2 points on the outside of the circle, but it is not a diameter. So we go up, we're going to say DG, and we're going to use our line segment symbol to show that that is the answer to the example of a chord in the diagram. So again, just want to note all three of these are line segments, and so their answers look similar. They all have two letters with the line segment symbol above it. All right, secant line. Now we're looking at lines. So these are going to be examples of things that go on beyond the circle. They have arrows on the ends of their lines. And a secant line is a line that crosses the circle twice. We have an example here. This line here crosses through the circle at point C and point D. You could use any of the points B, C, and D to name this, but we'll go ahead and call this CD, and we'll use the line symbol, which includes arrows on the end, to indicate that it is a line and not a line segment. Again, a secant line crosses through the circle in two places. Now, tangent line. Tangent line is going to be a line that just touches the circle. It doesn't cross inside, it just touches the very edge of the circle and then continues on. You can see an example here at point H. This line that goes from B to J touches there at point H. That is a tangent line. You could use any combination of points B, H, or J to name this line. So again, any of those, but you're definitely going to use the arrow ends to indicate that it is a line. We'll use HJ, and we'll use the line endings to show that's a line. All right, The next thing is asking about the name of the circle. The name of the circle is pretty straightforward. You name circles by naming the center of the circle. So this center of the circle is A, and so this is called circle A. So we can just write the words circle A, or we can use a symbol to show circle. Like I said, we can write circle A, or we can just use the symbol for circle, which is like a little circle with a dot in the middle. We could write circle A, or the symbol version is circle A written that way. That's pretty much it. So you just need to know that to name a circle, you write the letter that is the center of that circle. All right, the next group is all angles. So all of our answers are going to be angles that are 3 letters with the angle symbol. So the first one here is our inscribed angle. An inscribed angle is an angle where all 3 points are on the edge of the circle. And that means the angle is kind of contained within the circle. The central angle, which is what I'm looking at now, is the angle that has the center of the circle as its vertex. This is an example here, FAG or GAF in red is a central angle. So we'd write angle FAG, and that is the central angle shown there. Central angles, again, have the center of the circle as its vertex. So the A needs to be in the middle of that name because the A is the vertex. All right, backtracking to inscribed angle. Again, this is an angle where all the points are on the edge of the circle, and it's going to be completely contained within the circle. So we have C, D, and G. Those 3 points are on the edge of the circle, and when we connect them, we get this angle here. Angle CDG or angle GDC. Either way you put it is fine. You can see it there in blue, and so we'll go and write our answer saying angle CDG. And that's an inscribed angle. All right, the last one on this page is a secant tangent angle. A secant tangent angle is an angle that is made up of a secant and a tangent line together. So we need to find those. We should have already found them earlier, but we can see that our secant line and our tangent line intersect at point B. So there's my secant line, and then separately there's my tangent line. Those 2 lines are marked in green, and that's the angle that is being made by those 2 sides. You could name this a variety of ways, but I'll just choose to use the exterior points to do D. B is the vertex, and then J. So D, B, J would be the name of that angle shown in green, which is a secant tangent angle. Again, just made up of a secant line and a tangent line together. All right. So, moving down to the next section. Sorry, give me just a second to get this down here. All right. Now, this is going to move into a section about arcs and angles. In this section, we're being asked to name arcs or angles that go with a angle or arc that's given. So something to remember here is that we have minor arcs and major arcs, and every angle has a minor and major arc that goes with it, and every arc has an angle that goes with it. So, looking at the first one, we want to find a minor arc that goes with angle SQR. We can see that angle SQR is located right here. Sorry, give me just a minute to get this. There we go. SQR is the angle. And then looking outside of that, we see on the edge of the circle, we have this arc SR. That is the minor arc because it is the arc that connects points S and point R directly. and we name it using 2 letters with a curved line above the 2 letters showing that that is an arc. Minor arcs are always named with just 2 letters. You also notice that S and R were also the letters that were the part of the name of the angle. They were the 2 arms of the angle, so you can use that to your advantage. In the next one, we're looking for a major arc this time, and we're looking at a major arc for angle SQT. So here's where SQT is located. There's SQT. The major arc is not the one that goes between S and T directly. It is going to go from S to T, but it's going to go around the circle the long way. It's going to go this way, not the short way. All the way from S to T, around the long way, and any point it touches along the way can be used to create its name. We are going to name this SRT. It's going to be 3 letters underneath that arc, showing me I'm going from S to T, and I'm touching R along the way. That is how you name a major arc. Major arcs always have 3 names, 3-letter names. Lastly, in this section, we are going to name a central angle. So we're being given the name of an arc. We're being given the name of arc ST. Here's arc ST. And we want to name the angle that makes it. And the angle that makes it crosses through S, and it crosses through T, and it creates this angle here, angle SQT. And so we write our answer as an angle with the angle symbol, and then SQT because Q is the vertex of the angle. So that's all about naming. That's going to be one part of the test. But next, we're going to look at a section where we actually have to calculate the values of the arcs and the angles in a diagram where there's some given values. So one of the things that we're going to look at, I'm just going to mark these up real quick so that they're marked with the symbols. We're looking at the arcs. So one thing to note is that all of the arcs outside of those angles have the same measure of the angle that they are created by. So that 52 gets copied out, that 60 gets copied out, and that's something that we know right away. We also know this is a 90-degree angle because that's a right angle, and so the 90 also gets copied out there. So we actually know quite a bit about this figure, and now it's just a matter of filling in the rest. Something that's really important for you to remember on this is that the measure of an entire circle is 360, and the measure of a semicircle is just 180, and we're going to use those. In fact, we see that we have a semicircle here surrounding the 60-degree angle, and then the other angle that makes up that whole semicircle. So if we subtract 60 from 180, then we're going to find the measure of that other part right here, which is 120, and then of course the arc also would be 120 for that reason. And we're going to do the same thing on the bottom half. So again, we have another semicircle. We have a semicircle that goes all the way around the other side that encapsulates the 90 and the 52, and then this other little sliver. And we can find that sliver by subtracting from 180, 90, and 52. Oops. Not 92. 52 and 90. And we subtract those, we get 38. That is the measure of the angle marked with a question mark and the arc that is outside of that angle. Let me just erase this. Oops. Get my eraser tool. There we go. And so that 38 is also going to be 38 outside. So now we kind of know everything, and the rest of this is just filling in the answers to the questions. So the first, or number 4 rather, says, what is the measure of arc DE? Well, we just found that. Arc DE is 38 degrees. Then what is the measure of CEF? Okay, CEF is going to go all the way around the circle from C to F. It's going to hit E along the way. So we need to add up the measures of the 90, the 38, and the 120. So we add those up. That's going to be the total arc length, or not arc length, but the measure of the arc from CEF. And when we add those up, we get 248. Lastly, arc ECB. I'm going to erase everything so I can show you this one. Arc ECB is also known as, and I already said this earlier when I was talking about the circle, the half of the circle, this is a semicircle. A semicircle is half of a circle, and we know that a semicircle equals 180. All right. All right, scrolling down, where the next section is going to be our calculating the values of the angles. You have notes on this. You have notes that tell you all about the different types of angles. This first one is an example of an inscribed angle. Inscribed angles always have half the measure of the arc that they make. In fact, in this whole section, you're going to be doing either half of something or double. In this case, because NP is 100, the angle that is inside there is 50 degrees because it's half the measure of the arc. Always going to be half. Very straightforward. You're just doing either half or you're doing double. We are doing half because we are going from the arc to the angle. Next one, very similar except in reverse. We know that we have a 55 degree angle, but that 55 degree angle intersects the arc AC. And so if it is the angle that intersects that arc, then the arc would be 110. And we're just getting that by doing times 2 on the 55. Then we take the half of the circle, or the semicircle, we subtract the 110 that we found to find the remaining part of that, which is this 70 here. So together, 110 and 70 add up to 180, and that's how I know those values work for those two parts, those two arcs of the circle. Next one looks complicated, but it's not too bad. You either go again from arc to angle or angle to arc. So if we look at our 45 degree angle, that's going to be times 2 to find the arc, and that tells me that arc DC is 90. On the other hand, starting from 76, if I go into the angle from 76, that angle is going to be half the measure of that arc, which is 38 degrees. Again, it looks complicated, but really it's either half or double, depending on what it is. Either you're going from arc to angle, that's half, or angle to arc, that's double. All right. Looking down into the next section, we've got more of these. All right, looking at this back page, we're looking at secant tangent angles. This arc 124 is the arc that is made up of the secant tangent angle BAD. So then BAD is 62 degrees. And then on the other side of this, you have another angle. That angle has to be supplementary with 62. And so then that is going to be 180 minus 62 is going to give you 118. All right, looking at the next one, it's very similar. We have 94 degrees. We have that 94 means this angle 1 is 47 because it's half the arc. And then we look onto the other side and we do the same thing again. We have a linear pair that together add up to 180. So we do 180 minus 47, and that gives us 133. All right, then we look at the bottom. These are intersecting secants. This one's just that the fact that the angles that make up these two arcs, 144 and 126, you add them together and divide by 2. It's the average of those two arcs, 144, the AD, and arc BC, which is 126. We need to add those up and divide the sum by 2, and the resulting answer will be the measure of both of the angles around point E. In this case, we get 270 divided by 2 is 135. And that is the measure of the angles inside, including angle AED. All right. Looking down to the next page, we're going to be dealing with the formula charts that we had worked with previously. These are going to be the radius, diameter, circumference, and area situations. You're either going to be given the radius or the diameter. In this case, we have a radius of 15 centimeters in this first problem. I guess before that, I should just say the formulas for the circumference and area are as follows. The circumference is equal to 2 times pi times r. This is all in your formula chart. And the area formula is pi times r squared. So those are our formulas. I'll keep those there so we can use those as we go. On our first problem, the radius is 15 centimeters. That's the distance from the center of the circle to the outside. And the diameter is exactly twice as much. Always, the diameter is twice as much as the radius. So the diameter in this case is going to be 30 centimeters. You're always just going to simply double the radius to find the diameter. Then we do our circumference formula. We're going to take the r value and we're going to plug it into our formula. C equals 2 times pi times 15. Except I'm not going to do anything with pi. I'm only going to calculate the number part. 2 times 15 is 30. So then my answer is going to be 30 pi centimeters. Notice I'm just leaving pi on the end. I'm not calculating 3.14 or anything like that. I'm just calculating the number part of the answer. Now for the area formula is pi r squared. What's my radius? 15 again. So I'm going to go in here. I'm going to put 15 where the radius goes. And then I'm going to do 15 times 15. 15 times 15 is 225 pi centimeters squared. Notice again, I'm not doing anything with pi. I'm just bringing it through to the end of the problem, as you can see here. All right. We'll do one more. I'll move a little bit quicker on this one just because we've seen a lot of examples of these in class. So looking at my next problem, I'm also given the radius here. That's 8 centimeters. Like I said earlier, diameter is twice as much. So the diameter is 16 centimeters. 8 times 2. Then I grab my circumference formula. 2 times pi times r, which is 8. And then I just simply multiply the 2 times 8, and I get 16 pi centimeters. Again, not doing anything about pi. I'm just bringing pi through to the end of the problem. My area formula is pi times r squared, which in this case is 8 for my r. 8 times 8 is 64. So it's going to be 64 pi centimeters squared. And that is it. Those are the two formulas that you need for that to find the circumference and area using the radius. All right. I'll leave the rest of those problems on there for you to do, and you can check the answer key out in your classrooms. Scrolling down. I'm going to do a sector area problem. The sector area and arc length. Sector area and arc length are similar to the circumference and area formulas that we had before. The formula for area, or sector area is m times 360, m divided by 360 times pi r squared, and the arc length is m divided by 360 times 2 pi r. As you can see, all it is the circumference and area formulas with this additional fraction, m divided by 360. That m divided by 360 is accounting for the angle that you are using in the circle. So it's asking how much out of the full 360 is being included. Well, that angle is telling us, in this case, that 150 is the m value. That's how much of the angle of the 360 is being used. And the r value is given, it's 12. So for sector area, Instead of m, I'm going to put 150 divided by 360 times pi times r squared. All right, let me fix my pi. It's a little messy. Again, times 150 divided by 360 times pi times 12 squared. And then all I'm going to do is I am going to calculate the number part of this. I'm going to show you what parts I'm talking about. I'm doing the 150 divided by the 360. Then I'm multiplying it times 12 squared. I'm not doing anything with a pi. Just like the previous section, the pi is going to be left at the end. So when I do all of that, 150 divided by 360 times 12 squared, I get 60. And then it's 60 pi yards squared. That is the sector area. Again, notice I'm bringing the pi over. I'm not calculating its value. It's being left there as a placeholder. For the arc length, again, I'm doing m divided by 360, which is the same as the previous one. 150 divided by 360 times 2 times pi times r, which is 12. Again, I'm only going to calculate the number part. I'm going to do 150 divided by 360 times 2 times 12. When I do all of that, sorry, I wanted to show you real quick how these are the things you're actually calculating, those highlighted items. I'm not doing anything with pi. And the result is 10 pi yards. That's the result you get when you divide 150 divided by 360 times 2 times 12, and you bring the pi over. That is the arc length. That is it. The rest of these problems are for you to do. Most of this test is knowing how to identify the different parts of a circle. And then you have these two formulas. Don't forget, you get to use those formulas on the test. You also get to use the information about inscribed angles, central angles, and secant tangent angles.